everybody. Welcome to episode number 599 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Yes, this week's podcast is about electric vertical takeoff and landing aircraft. Matt McAlonis from TE Connectivity and I explore the biggest design challenges for eVTOLs, strategies for managing power effectively within eVTOL systems, the complexities of complying with new eVTOL certification requirements, and what Matt thinks it will take for eVTOL aircraft to become mainstream. So, without further ado, please welcome Matt to Fish Fry. Hi, Matt. Thank you so much for joining me.
Hi, Amelia. Great to talk to you today.
Excellent. Okay, so we're talking about the emerging eVTOL market today. But, Matt, what do you think are the biggest design challenges you're seeing in this space?
It's a great question and a complicated question. Any type of new technology will have lots of new things to learn and areas to innovate. And as with anything that needs to move in 3 dimensions and needs to fly around, weight is one of the most important elements to consider. And especially when you're trying to do things electric, you have a unique situation where the fuel is not being burned off and consumed, or the flying energy, you could call it. So the batteries are discharging, but not getting any lighter, where typical flight, you would be flying around and consuming fuel. Therefore, you get more efficient as you fly. So flying around that dead weight is one of the main challenges. And as a consequence, we have a need to further optimize our flight components. And if you're doing electric motors and batteries, you need a way to connect those. So part of what TE provides is the terminals, the wires and cables, and the connectors connecting all these systems. And, another thing that further complicates this, in traditional aircraft, we're typically generating power, through a generator on the engine, just like your car has an alternator. These are usually static types of environments. In other words, the alternator is fixed, the motors are fixed, and the propulsion or propeller, might have a little bit of articulation, but not to the degree of eVTOL. So eVTOL, a lot of the designs today have a, vertical takeoff position. And as you ascend and you want to go into a translation flight for efficiency, they will turn and articulate the motor. And so this articulation on a cable is something new. Generally the power cables are not designed for that type of flex endurance. So that's, again, a new area that we're required to provide that functionality, characterize it, and it also probably becomes an additional maintenance item on the aircraft. So then that opens up the door of serviceability. Most cables are usually invisible to the airplane from the outside. So now if you have to change out that cable, that creates an opportunity to do maintenance on it and ease of maintenance, quick maintenance. So those are just a few of the new challenges that we're seeing from the electrical system, and how do we enhance weight and optimize.
That makes sense. Now, Matt, we also need to address power management as well, right? With eVTOLs, we're dealing with safety issues with power required for these systems, correct?
So another area that has changed in the aircraft are the voltage levels. As you know, the high voltage is very dangerous, especially when it discharges in a way that it's not intended. And so we have to be very careful with these increased voltage levels. So that paradox then is, how do you manage that? And it's typically thickening the insulation materials, which obviously that's adding weight. So characterizing the power capabilities And another element here that exacerbates the situation is altitude. So, at higher altitude, the air is thinner, and therefore the voltage discharge can happen sooner at lower levels. So, we have to do a voltage calculation for altitude. But the thing in our benefit is most commercial aerospace products are rated at very high altitudes, much higher than they fly even. So typical commercial airplanes are flying 30 to 40,000 feet, but we rate our products usually above 70,000 feet. But an eVTOL can't fly that high or won't fly that high. The air density won't enable that. And typically it's flying shorter distances. So we can then characterize at altitude, usually around, say, 15,000 feet. So what that means is the installation can be further optimized for weight reduction. So when we deal with power and safety with increased voltages, and usually these are around 800 to 1,000 volt versus in the 200s for traditional commercial aircraft. So everything has to be considered there. In addition, with electrical power, typically we don't have connectors in the pin and socket connector sense. They're typically terminal lugs that are bolted down and can't move. So we have some new challenges with traditional pin and socket connectors that we've innovated in that area to make them more reliable. In high vibe environments, you want to make sure that the contact systems are stable. If they move, they can wear, and premature wear creates higher resistance, and higher resistance creates a thermal runaway situation that can be dangerous and turn into a fire and melt things around it. So all these things with power management are important. And in addition to the connectivity, the power switching is an area that we work on. So that involves newer technology like solid state technology, where the power switching can be electronically controlled versus electromechanically controlled, where you can have higher degrees of arcing. So a lot of pieces in here are considered with power management, and T is involved with all of these, from the generation and power management and power switching throughout the whole architecture.
So, Matt, scalability is also an important aspect of this market as well. So, how do you think we can ensure scalability for a global adoption of eVTOLs?
So this is, what we call a nascent or emerging market. So a lot of new products being developed, and the pedigree of a company like TE is we've been making products for decades. In fact, some of our aerospace products goes way back into the 40s and 50s, 1950s. And we have brands like AMP, which stood for Aircraft Marine Products, and Raychem, which is our primary aerospace cable brand. And so because we've been making these products for decades, we can leverage our existing scalability for that. So even though we have some potential new designs for optimized eVTOL platforms, we do have that global footprint where we make products around the globe. And so we can supply products to our customers on virtually any continent and give them that ability to scale as they grow in this new market.
So, certification, we should talk about that as well. It is a huge issue with eVTOLs. So, talk to me about the challenges of complying with eVTOL certification requirements.
So certification is extremely important. The last thing you want to do is have an unsafe type of vehicle platform in a market. And certification is also very expensive. For a typical aircraft, it could cost about $1 billion to get everything certified. And certification, it involves really 4 different areas that you have to get certified. One is the designs get certified, how they're built gets certified, how they're tested gets certified, and how they're used in the applications get certified. And then if you combine things like, is it piloted or is it autonomous? All these things can be new types of technologies that maybe haven't been done before. There's a lot of new things happening, and even the way they're used with, let's just say, like the taxi or maybe drone delivery type of service. There's a lot of new things. And if you think about just say your personal transport like Uber, Would you be able to call that up? And is it hack proof? Can somebody take this thing over somehow, whether they're inside of it or external to it? So there's a lot of things that have to be thought through for certification. We typically would deal with the product certification. And in the product certification, our designs have to be built on products that we know work. So they're reliable systems. The pedigree that we have is important to represent that in our new designs as well. So the chemical formulations we make our materials from and the constructions that we make our products out of. So those are all very important things that we have a good understanding of them. In aerospace, things have to last a long time. They're not really disposable products like in the commercial world. If your USB cable doesn't work, buy a new one, throw it away. But if something doesn't work in an aircraft, that's a bigger issue. And even, we talk about if you have an issue when you're flying, you can't just pull over, you drop. And especially in a helicopter, you're typically flying in terrain that you may not have a good place to land initially. So you have to really make sure that the airspace is certified, how we're using them, the flights, the types of products used, and the standardization of maintenance schedules, product reliability expectations. So there is a lot in certification, and this isn't getting any easier. The FAA certainly has to do its due diligence, especially in the industry. There have been some, issues that the public's aware of, some of the headlines that you've heard about in the past few years. So there should be a degree of scrutiny on any new technologies to make sure it is vetted and the products are safe to use in the industry.
So you talked about this a bit, but Matt, tell me, how is TE Connectivity supporting this eVTOL revolution?
Part of the way TE approaches markets like this is we have teams that look at what we call system architecture. So personally, I have a team called Advanced Systems and Architecture, and we look at the industry needs, say, 5 to 10 years out. So some of the long horizon needs. And part of what we know we have to do is optimize things for the size and shape that they have to be packaged in, and weight reduction, as we've talked about, and better power efficiency. So because we're a critical link between the motor and the battery, and we do the power switching in there, we are supporting all elements of it because we don't want to have any weak links in there, and we want to understand the full product ecosystem that we're enabling. And so we look at things like new materials and advanced conductor materials, advanced insulation and wire construction materials, and also the power switching, like the solid state technology that we're developing. So as we're working on the products, we also support our customers. So we like to visit our customers and make them aware of the new technology roadmaps that we're developing and the product roadmaps that will follow the technology developments, but also see the problems they're trying to solve. And so they're typically very open to show us what they're trying to do, where their challenges are. And often it's, building these new vehicles. And so as they're building vehicles, we can give them insights into products that they may not be aware of. We also work in standards, and the standards create markets for everyone. And these are not just the products that are flying, but also the ones that may be ground-based that do charging. And so how do we also support the ground-based infrastructure and some of the other aerospace management systems that are required for a new market like this?
Okay, last big question to throw your way, Matt. If you had to guess, how long do you think it's going to take until we get to see a wide adoption of eVTOL technology?
A few years ago, the goal was to have eVTOLs flying at the Paris Olympics. And obviously that did not happen, or just on the back end of that. But the thing that was exciting this year, even, we had a booth at the Paris Air Show this year, and there were many, many eVTOL companies representing their products in static displays at the show. But there was also flying demonstrators of eVTOL. And it was exciting to see, for the first time, I think, at least in a large event like that, a public display. And literally every day they would show these eVTOLs flying very quiet. And it kind of really gave a sense of reality that it is here. Now, there's a lot involved with getting it for wide adoption. Giving people a helicopter ride experience will be good, because I think that's one of the things where, if you ask people, they're probably excited about new technology options like this. But when it comes down to, would you do that selection, say on your app to select your ride share or whatever, would you pick that one and would you actually fly it? Would you feel it's safe? Would you enjoy the ride experience? And so those are some things that I think the society needs to really understand the benefit to the community at large. So if we're solving areas of, say, traffic congestion, or maybe hard to reach areas where, there typically aren't good roads to get here or there, or even say search and rescue, or, other types of things, like there could be, some really good applications for some of this new eVTOL technology. So, I feel like even though we did not hit the goal of Paris Olympics, which was set a few years ago, we are seeing companies do their flight tests, and it is probably a couple years away, I would say, but it's absolutely within reach and truly possible.
I love it. All right, Matt, before I let you go, it's time for your off the cuff question. So, Matt, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
I would have a grilled salmon fillet on a salad with some blueberries on it.
That sounds delicious.
I'm in the mood for that right now.
Fantastic. Well, Matt, it was a pleasure speaking with you. Thank you so much for joining me.
Thanks, Amelia. Take care.
Next week is my 600th episode, you guys. And my very special guest is an expert in the world of battery chemistry innovation, Dr. Bo Zhang. Dr. Zhang was awarded the very first patent application on graphene way back in 2002. And that patent was later recognized in the Popular Mechanics 15 patents that changed the world. Dr. Zhang was also the Dean of the College of Engineering and Computer Science at Wright State University. And in 2019, Dr. Zhang was elected as a member of the U.S. National Academy of Inventors. So it goes without saying that I am super excited to celebrate my 600th episode with a heavyweight in the world of battery innovation. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into X, you can monitor our tweets at EEJournalTFM. And don't forget, if you would like to follow my personal account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn as well. And we are also on Blue Sky Social and Mastodon too. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and our brand new animated series called Libby's Lab. And of course, you can subscribe to our EE Journal YouTube channel as well. Also, make sure that you subscribe to this here podcast on Spotify, Podbean, Apple Podcasts, YouTube, or just about any other podcasting platform to listen to some exciting upcoming episodes. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of September 13th, 2024, I'm Amelia Dalton, and you've been fried.